This video shows annotation, training, and deployment workflow within the Relimetrics Trainer. In this demo, we are working with server components. Specifically, we'll be training a model to check the configuration of dim latches. Let's get started. In this session, acquired server images are shown in the image gallery. These images contain different configuration of dims. Clicking on an image triggers the annotation view, where specific regions of interest in the image can be annotated for training. The first step in the annotation process is the definition of possible states. The pop-up dialog allows to define a group name and its corresponding states. In this case, we are creating a latch group for dim latches and define possible states as open and closed. Let's now use the rectangle drawing tool to select the dim latch. Any selected region of interest can be quickly replicated using duplicate tool. Once a region is selected in an image, the selected region can be applied to every image in the stack. This speeds up the annotation process. Appropriate states, which match the underlying image, are assigned to each region of interest. In case of this image, all latches are closed. View of an ROI properties modification dialog. It is used if an ROI needs to be modified after creation. Here, no modification is applied. Let's now switch to the next image in the stack. One can notice that the region of interest rectangles are already defined, as mentioned previously. The only task to do is to assign correct state to each of them. To get ready for training, let's open another session which already contains a fully prepared dataset with all dim latches drawn and their states assigned. We go back to the gallery screen to prepare the training dataset to train a deep learning model for latches. The first step is to extract the selected regions of interest as a separate stack of images which will be directly fed into the training pipeline. To achieve this, we create a new image set from the latch ROI group. Here you see that the new image set consists of only latches. The system can automatically split the dataset into training and validation parts, or the user can split the set manually. Images selected for training and validation can be previewed. Here, a 0.4 split ratio used, which means 60% of images are selected to train the model and 40% of them to validate the model. This ratio is commonly used in deep learning training to create a balanced dataset. Let's now enter the training view, select our latch dataset as the training input, and train a new model using the local training backend. Remote and cloud training options can be used to perform the training in more powerful machines. Start Training button launches the training process. For convenience, the video is fast-forwarded during this process. While the training progresses, the user can see model loss and accuracy plots. These plots are used to determine how well the training is proceeding. At the end of the training, the view switches to Evaluation tab, which allows to inspect the statistics of the training. It shows number of training images, final accuracy, and training time. In the audit view, the performance of the newly trained model can be tested using live images from the audit system. Let's now deploy the trained model. In this example, the audit system is configured to check two predefined configurations, empty and filled configuration. The status report shows that one slot is misconfigured with a very high confidence level. Let's inspect more closely if this is indeed the case. The annotations can be switched off to get better visibility of the audit image. Zooming into the detected fault shows that the system correctly flagged an unlatched latch. For more information on Relimetrics Trainer, contact info@relimetrics.com.